I'm Louisa Troitzsch, a carbon management master's student with the University of Edinburgh, and today I'm going to talk about the present and future impacts of climate change in Zurich, Switzerland. But first, let me introduce you to the city. Located at the heart of Europe, Switzerland is a landlocked country, neighboured by Germany to the north, France to the west, Italy to the south, and Austria and Liechtenstein to the east. Zurich is the largest city in Switzerland, with a population of around 380,000. The main station is a major European rail hub with direct connections to many European cities including Milan, Paris and Vienna. The city is built around the Zürichsee, or Lake Zurich, which is not only the main source of drinking water for the city, but also a popular bathing spot in the summer, when its temperature often exceeds 20 degrees Celsius. Two rivers also run through the city, the Limmat, which flows from Lake Zurich, and the Ziel, which flows from the Drusberg mountain via the man-made Zielsee underneath Zurich main station and eventually converges with the Limmat just north of Zurich city centre. Zurich is a key financial centre, with the finance industry accounting for around 1/3 of the city's wealth and around 1/4 of its jobs. It's also home to two major universities, the Swiss Federal Institute of Technology, or ETH, and the University of Zurich, and is an innovation hub with over 1,500 startups headquartered in the city. Aside from the historic buildings found in Zurich's Old Town, the majority of buildings in Zurich were built in the early to mid-20th century, although this housing stock is rapidly being replaced as evidenced by the extensive building works around the city. Zurich has a temperate climate with 4 distinct seasons. The 30-year mean daytime maximum temperature is 23 degrees Celsius in July and August, contrasting with a 30-year mean daytime minimum temperature of minus 2 degrees Celsius in January and February. An average of around 1,000 millimetres of precipitation falls fairly evenly throughout the year, with December typically being the wettest month of the year, with an average of 95 millimetres of precipitation. The summer of 2018 saw record warm temperatures, with an average air temperature of 17.5 degrees Celsius between April and September, the so-called summer half of the year or summer months. This was the highest recorded average temperature for the summer months since records began in 1864. In fact, 9 of the 10 warmest summer months have fallen within the 15 years since 2003, and the mean summer temperature in the 21st century is 2 degrees Celsius warmer than that recorded in the 20th century. In addition to the higher average temperature during these summer months, Zurich also experienced 18 very hot days in 2018, where the temperature rose above 30 degrees Celsius. This is significantly more than the average of 6 very hot days in the period since 1864, and was exceeded only in 1947, 2003 and 2015, each of which experienced more than 25 very hot days. 2018 also saw the driest April to July in Zurich since 1901, and this dry spell was exacerbated by the unusually high temperatures. The Terce River, just north of the city of Zurich, completely dried out, and local farmers also felt the impact, with failing pesticides leading to higher incidence of crop pests, and earlier harvest times leading to uncertainty in supply chain. In the city, the higher temperatures and lack of precipitation were evidenced by the brown grass in the usually green parts of the city and the early arrival of autumn leaves. It is important to note that although there is a clear trend towards warmer temperatures in Zurich, the unusual dryness experienced in 2018 does not currently represent a climate trend. The last major flood event in Zurich was in 1910, and the city has of course changed and grown considerably since then, such that if there were a flood today, the impact would be significant. In 2005, Zurich narrowly avoided being impacted by the flooding that caused serious damage in other parts of Switzerland, in particular in the capital city of Bern. If the heaviest rain had fallen over the Ziel area rather than further west in the Berner Oberland, it is likely that much of the city of Zurich would have been flooded. Significantly, Zurich main station would have seen severe damages since the Ziel River flows directly underneath the tracks. As it was, however, the Zielsee remained just 4 centimetres below its limit, and the city of Zurich received a wake-up call to improve their flood resilience. In 2011, the Swiss Climate Change Scenarios CH 2011 report was published, with its latest update, CH 2018, due to be released in mid-November 2018. CH 2011 considers 3 climate scenarios: A2, which represents a more divided, locally focused world, A1b, which represents a more integrated world with a mixture of fossil fuels and non-fossil fuels, and RCP-3PD, also known as RCP 2.6, which sees rapid dramatic cuts in emissions resulting in CO2 concentrations peaking in around 2050, after which levels slowly decline. The CH 2011 report forecast that by the end of the century, the mean seasonal temperature in Switzerland would increase relative to the reference period of 1980 to 2009 by between 3.2 and 4.8 degrees Celsius under the A2 scenario, by between 2.7 and 4.1 degrees Celsius under the A1b scenario, and by between 1.2 and 1.8 degrees Celsius under the RCP 3PD stabilisation scenario. The report also predicted a drop in summer precipitation by the end of the century of 21 to 28% under the A2 scenario, 18 to 24% under A1b, and 8 to 10% under RCP 3PD. CH 2011 also highlighted the impact of climate change on extreme weather events. The higher summer temperatures are very likely to result in more frequent and intense heat waves, and the warmer winter temperatures could result in precipitation falling more often as rain rather than as snow, increasing the risk of flooding. Being a city, Zurich is also affected by the urban heat island effect and is therefore likely to be more severely impacted by rising temperatures. Additionally, much of the city's ground is sealed, being paved with roads or built upon, and is therefore less able to absorb additional water brought by an extreme precipitation event. It was reported that during the 2003 European heatwave, around 1,000 people in Switzerland died as a result of the elevated temperatures. Although the impact was felt more strongly in the cities of Geneva, Basel and Lausanne, the population of Zurich was also affected, with an increase of 12.3% in deaths of people over 64 in comparison to summer 2002. In addition to the direct health impacts of the heat, such as dehydration, heat stroke and cardiac problems, Zurich's population is also likely to experience some indirect health impacts from climate change. For example, the warmer temperatures are likely to result in longer pollen seasons, affecting those with allergies, and higher ozone levels, leading to increased incidence of respiratory illnesses. Research has shown that productivity decreases when the room temperature exceeds 26 degrees Celsius. During the heatwave in 2003, it is estimated that this threshold was exceeded 22 times in 4 weeks in the average office in Zurich, in comparison to an average of 7 days per year. Given the high proportion of the population working in offices, the increased frequency of heatwaves could have a serious impact on Zurich's workforce if left unaddressed. Businesses in Zurich, and in particular its insurance and reinsurance companies, could also be impacted by the global effects of climate change, and in particular extreme weather events. In 2017, natural disasters including earthquakes in Mexico, wildfires in California, and hurricanes in North America resulted in Swiss Re reporting a net income of $331 million, a drop of 91% from the year ending December 2016. Of course, the purpose of insurance is to provide some financial protection to those affected by natural disasters, and the financial impact for the people of Zurich is in no way comparable to the impacts suffered by those directly affected by these catastrophic events. However, it will be interesting to see how the insurance and finance industry in Zurich will adapt to these changes in the future. Zurich is highly exposed to flooding due to its position on the debris fan of the Siel River. This is clearly evidenced in the convergence of the rivers Siel and Limmat, where, especially at times of heavy rain, the difference in water colour is notable. The density of buildings and infrastructure in the city centre increases the city's potential flood damage. Additionally, many businesses keep valuable goods on the ground floor or use underground storage, and the city's transport infrastructure is also partly underground, with road underpasses, underground car parks and many rail tunnels. It is estimated that if there were an extreme flood event in Zurich, an area of around 4 to 5 square kilometres would be affected, causing up to 5.5 billion francs of material damage. This amount excludes the subsequent costs, such as those caused by damaged transport and telecommunications infrastructure, which would also be considerable. With the Siel River running underneath the main station, serious flooding would be likely to result in the closure of the station, which would have a huge impact on travel within Switzerland and also a transboundary impact for connections within Europe. In spite of these potential risks of climate change in Switzerland, the country is well placed to adapt. Switzerland's high GDP means that there are funds available to develop and implement climate adaptation strategies. In Zurich, flood adaptation strategies have already been implemented following the near-miss flood event in 2005. For example, the riverbed of the section of the Siel which runs underneath the main station has been lowered, and a forecasting system put in place to determine when the Zielsee is likely to overreach its capacity, allowing the lake to be partially drained in advance of an extreme precipitation event. This system has already been used in May 2013 and July 2014. It is likely that Zurich will also experience some benefits from the warmer temperatures for the next 50 years at least. The Mediterraneanization of the climate could lead to an upturn in tourism in the summer months and, if there is sufficient rainfall, also increased opportunities for agriculture within the wider canton. Additionally, the higher temperatures in winter are likely to result in fewer cold-related deaths. To conclude, although Zurich will be impacted by climate change within the next century, with elevated temperatures, reduced summer precipitation, and increased risk of flooding, the city is well placed to adapt, and impacts will be significantly less than those felt in other parts of the world. Thank you for taking the time to find out about the impacts of climate change in Zurich.